question encountered references Table 430-152, which is a table found in the 1999 National Electrical Code, or NEC. This table does not exist in the 2002 NEC. The correct table in the 2002 NEC for the same information is Table 430.52. It is important to recognize that the National Electrical Code is updated and published every 3 years, which means that each new edition effectively replaces and supersedes the previous one. Throughout these updates, tables, sections, and entire articles may be added, removed, or renumbered. To ensure accuracy and compliance, one should always refer to the specific edition of the NEC that is adopted by the local jurisdiction or the edition that is relevant to the project at hand. The difference between Table 430-152 in the 1999 NEC and Table 430.52 in the 2002 NEC highlights the importance of using the correct code edition. When studying for an exam or working on a project, it is essential to verify the specific edition of the NEC that the exam or project is based on and use the corresponding tables and sections from that edition. Using the incorrect table or section can lead to incorrect answers on the exam or non-compliant electrical installations. When faced with discrepancies between different editions of the NEC, there are a few steps to take. Firstly, determine the edition of the NEC that applies to the specific situation. This information is typically provided in the exam instructions, project specifications, or local regulations. Secondly, obtain a copy of the relevant edition of the NEC. This can be a physical copy or an electronic version. Thirdly, locate the corresponding table or section in the correct edition of the NEC. In this case, if the question refers to Table 430-152, but the project is based on the 2002 NEC, then you should use Table 430.52 instead. Fourthly, carefully review the information in the table or section to ensure that you understand the requirements and apply them correctly. If there are any ambiguities or uncertainties, consult with a qualified electrical inspector or engineer for clarification. The updates in the NEC can involve various types of changes, including additions, removals, and renumbering of sections, tables, and articles. Additions introduce new requirements or guidelines that were not previously covered in the code. These additions may be based on new technologies, industry best practices, or emerging safety concerns. Removals eliminate outdated or unnecessary requirements that are no longer relevant or applicable. These removals may be based on changes in technology, industry standards, or safety regulations. Renumbering reorganizes the structure of the code, which can involve moving sections, tables, or articles to different locations. This renumbering may be done to improve the clarity, consistency, or logical flow of the code. It is important to be aware of these types of changes when transitioning from one edition of the NEC to another. Taking the time to review the changes and understand their implications can help to avoid confusion and ensure compliance with the latest requirements. In addition to the specific example of Table 430-152 versus Table 430.52, there are many other instances where the NEC has changed significantly from one edition to another. For example, the requirements for ground fault circuit interrupter, or GFCI, protection have been expanded over the years to include more locations and applications. The requirements for arc fault circuit interrupter, or FSI, protection have also been introduced and expanded to address the risk of electrical fires caused by arc faults. The requirements for renewable energy systems such as solar photovoltaic, or PV, systems and wind turbines have been added to address the growing popularity of these technologies. These are just a few examples of the many changes that have been made to the NEC over the years. To stay up to date with the latest requirements, it is important to continuously educate yourself on the changes and updates in each new edition of the code. This can be done by attending training courses, reading industry publications, and consulting with qualified electrical professionals. The NEC is a comprehensive document that covers a wide range of electrical topics. It is organized into articles, chapters, and sections, each addressing a specific area of electrical design, installation, and safety. The NEC also includes numerous tables, figures, and examples to illustrate the requirements and provide guidance to electrical professionals. Some of the key topics covered in the NEC include wiring methods, overcurrent protection, grounding and bonding, equipment installation, special occupancies, and communications systems. Each of these topics is addressed in detail, with specific requirements and guidelines to ensure safe and compliant electrical installations. The NEC is not intended to be a design manual or a substitute for engineering judgment. It is intended to provide a minimum standard for electrical safety, and it is up to qualified electrical professionals to apply their knowledge and experience to design and install electrical systems that meet the specific needs of each project. The NEC is also not intended to be a legal document or a substitute for local regulations. It is up to local jurisdictions to adopt and enforce the NEC, and they may also add or modify the requirements to suit their specific needs. It is important to check with the local authorities to determine which edition of the NEC is in effect and whether there are any local amendments or variations. In addition to the NEC, there are other standards and guidelines that may be relevant to electrical work. These include standards from organizations such as the Institute of Electrical and Electronics Engineers, or IEE, the National Fire Protection Association, or NFPA, and Underwriters Laboratories, or UL. These standards cover a wide range of topics such as electrical safety, equipment performance, and testing procedures. It is important to be familiar with these standards and guidelines and to apply them as appropriate to ensure safe and reliable electrical installations. When working on electrical projects, it is important to follow a systematic approach to ensure that all requirements are met. This approach should include the following steps. Firstly, define the scope of the project, including the type of electrical system, the location of the installation, and the intended use of the equipment. Secondly, identify the applicable codes and standards, including the NEC local regulations and other relevant guidelines. Thirdly, develop a detailed design that meets the requirements of the applicable codes and standards. This design should include drawings, specifications, and calculations. Fourthly, obtain the necessary permits and approvals from the local authorities. Fifthly, install the electrical system according to the approved design and the applicable codes and standards. Sixthly, inspect and test the electrical system to ensure that it is safe and compliant. Seventhly, document the installation and provide training to the users of the equipment. Following these steps can help to ensure that electrical projects are completed safely, efficiently, and in compliance with all applicable requirements. Electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others from electrical hazards. Some of the key safety precautions include de-energizing circuits before working on them, using appropriate personal protective equipment, or PPE, such as gloves and safety glasses, following lockout/tagout procedures to prevent accidental energization, and testing circuits to verify that they are de-energized. It is also important to be aware of the potential hazards associated with specific types of electrical equipment, such as transformers, generators, and batteries. These hazards can include electric shock, arc flash, and exposure to hazardous materials. Taking the time to learn about these hazards and to follow the appropriate safety precautions can help to prevent accidents and injuries. Electrical safety is not just the responsibility of electrical professionals. Everyone can play a role in preventing electrical accidents by following basic safety rules, such as keeping electrical cords and appliances away from water, avoiding overloading circuits, and reporting any electrical hazards to the appropriate authorities. Educating yourself and others about electrical safety can help to create a safer environment for everyone. In conclusion, understanding the NEC and following proper electrical safety practices are essential for electrical professionals and anyone working with electricity. By staying up to date with the latest code requirements, following a systematic approach to electrical projects, and taking all necessary safety precautions, you can help to ensure safe, reliable, and compliant electrical installations. Remember to always prioritize safety and to consult with qualified electrical professionals if you have any questions or concerns.